All right, so let's get rolling on this. So what we're going to cover today through the DSP portion, we're going to do a walkthrough, and at the end, we're going to go through the software itself for those of you that want to go through it. Originally, we weren't going to do a lot of PowerPoint stuff, but it was going to be easier to integrate this into the PowerPoint. One of the biggest things is we get a lot of phone calls from people talking about how do I set this up? What are the key steps? Let me be straight with one thing. There is no tuning process out there that is going to fit every application and every need. This tuning process that we're going to go through today is very specific. I'm going to give you a visual demonstration showing of the system that we're tuning for in a very specific vehicle. The idea here is we are trying to give everybody a fundamental base of process and steps in order to be able to get themselves going in a DSP. There is no book out there, and we're going to talk about some different options and things you're going to hear out there, but trying to keep a textbook step process for you in regards to DSPs. So first thing, what's this course about? It's a review of today's DSP challenges. It's also a walkthrough of simple and reproducible tuning procedures and considerations to creating great sound, and using these steps to create a platform or a reference of sound allowing you to tune for the owner's needs. Now, or the listener's needs if you are the owner. The thing to remember here is if you are a shop, you're tuning for the customer. If you're an owner and you're tuning for yourself, remember you have to correct the acoustical environment in the car before you can actually tune for the environment, which is what this course is about. So first things first, the challenge of today's DSPs. The internet is a wonderful thing, but it's also a horrible thing at the same time. There's way too many experts. And I know you're like, well, you guys are sitting here broadcasting this too, but we're giving you an opinion. We're giving you a proven direction that works for many and is a good starting point to get people working through a process. There's way too many opinions, whether it's eggs, steaks, or stereos. When we're cooking eggs, we're still cooking eggs. It's the same thing. At the end, we just want them cooked. And there's so many different ways to cook an egg platter. Steaks and stereos are the same way. Ultimately, if it's an egg breakfast, we're going to eat it. If it's a steak, we're going to eat it. If it's a stereo, we're going to listen to it. And the one thing we want is we all want music to sound great. So the thing is if you're out on the internet, you're going to be hearing a lot of different opinions from a lot of different people on how to process a system and how to tune. And you have to remember one very careful thing here, and that is that everybody's opinion is considered more or less like a doorway. And what is the one thing we know about doorways, and that is that all doors lead to the hallway. We're all trying to achieve the same thing. So the number one thing I can say right now is you're going to get a lot of these opinions, but there's also an area that you have to be concerned about, and that is you're going to find people out there that are going to say, my way is the only way, and I'm the only one that knows right, and everybody else is out of their mind. So, and I'm sure we all know that, so feel free to stick a photo right there in the presentation if you'd like to whoever that professional is that saying that. But the other important thing is once you start learning a way that works for you, most importantly is practice, practice, practice. This isn't like the days of 31 band EQs. You have DSPs. Program it, learn it, tune it, restart. You can save the file for a later date. Never be afraid to start over, because sometimes if you just work off of what you already had, the issue here is you end up, maybe you're fixing a mistake versus learning to correct those mistakes as you go through the process. There's also so many features in a lot of these DSPs, and in some cases people get confused. At the end of the day, it's a crossover, it's signal delay, and it's an EQ, which most every one of us have ever used. Simplify the breakdown of what a DSP is and forget all the buttons for a minute, and you start realizing it's actually a very simple tool to use. And we all want it simple. And there's been certain things as far as simplicity in DSPs, and it hasn't always necessarily delivered. We just have to remember that when we're doing these systems. So, starting list. Where are we checking? And I know some of these are going to be basic, but I've been to some places before and actually done trainings in person that we're supposed to have systems set up. But the first and most important thing is install the system. Trying to teach yourself about DSPs and tuning on a bench with a couple of speakers that are sitting there doesn't work. Doing a system that's only half installed and half playing doesn't work. Make sure everything is connected properly. Fusing, polarity on wiring, your RCAs, make sure you have signal passing through everything. These are some of the more important things that, honestly, if you don't make sure this is taken care of, you're going to have an uphill battle the whole way. Grounds, they need to be good and clean. You need to make sure that you don't have noise in the system. These are all things that are going to affect the performance of your system and the quality of the sound that you get for the end product. And this one seems so simple, but make sure everything is turned on. I can tell you a story after this is all over with on that one. And the other one is make sure you update your software and processor. We're going to go over that hands-on here at the end, but this is a big deal, especially if you're running a PS8, not a PS8 Pro or one of the Pro-Series DSPs, because there was no automated tools like in the new Pro-Series DSP that tells you if you're out of range of a update between the desktop software, the firmware, the DSP code, or the PSC. And you definitely need to make sure that you're up to date on anything PS8-wise. So first things first, where do we start? After we get the updates done, one of the areas we start to focus on is the setup panel. And this is my process that I use for setting up a system and getting people to where it's easy to use as a reference tool. It's easy to reference through the tuning process as far as the channels and everything go. And this area here is the first spot, and that is name all your inputs and outputs. You're going to have output labels, and then you're going to have input labels. It's always great to name those because it'll carry on through all the software in the through the system in the vehicle. And by having those names there, it's a quick reference, and it makes it easier for you to be able to tune, knowing what you're adjusting versus trying to remember what did I have on output 1 or output 2 or output 3. I gotta quit looking at chat. Who knows, Neil? Maybe. The next step, of course, is set and define your turn on and off and remote in out delays. Now, if you look over on the right-hand side, amp turn on delay, this has been a little bit of confusion for some people. So amp turn on delay is only relative to a few products. That's the PS850, and that's also any of the ARC series amplifiers with the IPS 8.8 built into it. Now, what this does is this physically sets the delay for the turn on to any DSP equipped product that has an amplifier built into it. So if you put the IPS 8.8 into the ARC series, it'll control that amplifier only. If you're controlling the PS850, it'll control the amplifier section of that amplifier only. The turn on out delay is something that controls the output trigger to additional amplifiers. You never want to hook up a DSP and all your amplifiers to the remote turn on output of your source, because you are 99 times out of 100 going to get turn on pop. So if you're running more than one amplifier, like if you're running a secondary amplifier off of a PS850, or if you're running a additional amplifier off of a ARC series amplifier with an IPS 8.8, always run it out of the turn on output. And this secondary control here, which is turn on out delay, is where you will actually make that adjustment to delay the turn on sequence of that additional amplifier. Or if you're running multiple processors, you run it in chain of this as well, and you can run that on the output of the first DSP. Turn on hold time is in regards to how long you want the internal muting circuit in the processor to stay turned on when you're shutting off your system in order to prevent turn off pop. And then auto sense hold time is if you are actually using an auto sense triggered system using either the signal detect or the DC detect. This will actually, as long as it senses the auto sense, will stay turned on. But if it loses the auto sense signal, it'll wait whatever your defined number of seconds here is set to before it tries to turn the system off. Crossovers. We are not going to get into this super deep because this will open up a can of worms in itself. Do remember that just a heads up, we're basing this off of a system that has already got the fundamental system set up, basically using an aftermarket 4-range head unit or something like the Maestro module. Crossovers, just a couple basic rules. High pass is HP, low pass is LP, band pass is where it cuts the signal off on both ends, for those of you that don't know. But the three basic rules of crossovers: it is not possible to stitch two different speakers together perfectly. A crossover should be as simple as possible to achieve the desired outcome, and the more complex the crossover, the more difficult it is to control. If you keep those fundamentals in place and try not to overanalyze it, there's a lot of great information out there, but if you don't have the basics down of crossovers, it's something that would be very, very difficult for you to control and be able to get your system to sound right. And then also, these are just a couple of rules, and I know there will be a couple engineers out there that are going to cringe when they read this. When possible, in a three-way system, select a mid-range driver that has an operational range of at least 200 hertz to 5,000 hertz. The reason being is 200 hertz to 5K in a three-way system in the front of the vehicle holds a lot of the key staging frequencies in a system. And the more speakers you have playing through that range, the harder it is going to be for you to get those, to get your staging where you want it to be. For those of you that are new to this, staging is where the sound sounds like it's coming from in the vehicle. Instead of sounding like it's coming down from the doors, it would sound like it's coming from up top on the dash with maybe a tweeter or a mid-and tweeter in three-way. Having multiple speakers in different locations or having a crossover point in the middle of that 200 hertz to 5K range can definitely increase the complexity of the system. And it could also greatly increase the complexity of how it gets tuned, and resulting in things like vocal staging shift, where a singer gets louder and you hear her move from one spot to the next, or the frequency starts causing instruments and vocals to wander all over the system versus sounding like you're at that live performance. And then when using a subwoofer mounted in the trunk, crossing over a subwoofer above 50 hertz can easily increase the sound of your subwoofers. A lot of people typically cross over a lot of those speakers at 85 hertz, 80 hertz. For street systems, you may be even louder. For an SQ system, you'll see a lot of people crossing them over well below 50 and 60 hertz, making sure that they have a great mid-bass driver up in the front, so that way they can try to couple everything at the front of the vehicle. Setting crossovers. Like I say, not going to get into a lot. Read the manual. Learn more about the speakers that you're using. Talk with the manufacturers to find out what the limitations are. Keep them simple. Keep those crossover points out of the staging frequencies. And also another great tool, have everything start with the 24 dB Linkwitz Riley. It's probably one of the smoothest and best starting places for any tuning session. And it's not rocket science. Don't overthink the process and keep it simple. I don't want to get into a lot more. I don't want to get into a lot more on it, because there's phase theory versus how crossovers are affected, and that will definitely be a training for a different day when we got a lot more time. All right, so our demo system for this training, which we're building it off of. Some of you may recognize this car. In this case, what we're doing for the system is RS 1.0 tweeters, RS 4.0 mid-ranges, both in pillars, and RS 6.0s. Now, I know you're probably going to say those aren't drivers. We're going to do a black series in the back too. But what we're going to go and do here real quick is we're going to install some RS drivers up in the front. Crossover points that we're using for the system, the RS 1.0s are high pass 24 dB Linkwitz Riley at 5,500 hertz and up. RS 4.0 is a band pass crossover at 24 dB from 175 to 5175. We have a slight underlap on there, and that is because of where some of the natural gain is in this particular vehicle. I usually do always recommend, if you are trying to get a very well-staging vehicle, to underlap those crossover points a little bit, so you don't get frequency gain between the drivers that would ultimately cause smearing. And the RS 6.0s are crossed over from 60 hertz up to 165. And the Black 12, in this case, still 24 dB Linkwitz Riley for now, and is crossed over at 55 hertz and down. So phase and delay. This is one of the areas that a lot of people have questions about: how to set phase, how to set delay in the system. And we're going to give you the basic concept of this. This is a process that our competition team has used. I've taught successfully overseas, and that I teach hands-on with the dealers. It gives a new meaning to hearing and understanding as you're doing versus letting something do it for you. So what is phase? Phase is basically, electrically, you have everything positive is positive, negative is negative. But acoustically, it's all the information is reaching itself in an equal cycle to the listening position in your ear. So you hear things like low frequency. You start hearing things like the natural center if you're dead smack between the speakers of the recording. And if it's not in phase, it's going to be extremely difficult for you to experience this. The downside to it, if it's out of phase, you're going to hear a loss of detail. It's going to smear a vocal clear across the entire stage of the vehicle. You're going to hear things being inaccurately placed, and you're going to pretty much lose all of your low frequencies. Anybody who's installed subwoofers and done more than one sub obviously has experienced that, where we've all done it. Wired one sub out of phase, hooked up the system, and there's no output because they're canceling each other. So many professionals, so many options. Get ready for this one, guys. Auto-tune DSPs. This is one option. We all seen this one before. It's a JBL and S8. It was a great tool because you put on a set of headphones, you turned your head left and right, got everything to a tuning point. And for most people, it actually was better than what a lot of people had heard, especially for anybody who didn't have any experience in being able to tune the DSP manually. It typically resulted in about 70 to 80% of the end average goal. The biggest concern is, of course, it doesn't teach you anything. So even though you had that EQ at the very end of it and you had some adjustability at the end of the process, you don't necessarily know what it did, why it did it, how it did it, or even, well, how to correct it. And most importantly, if it's working right. And each time you did it, it would yield a different result. It was never consistent. It's still no better. It's still no better than you were basically before you installed it, as far as an installer goes, and being able to further learning and developing your ability. The tape measure. This is, and of course, I'm sure a couple of people are holding their breath out there right now that I mentioned this. It is probably the fastest of the three options out there, aside from auto-tune. But the thing is it still yields average results. I've had people that have said, "Hey, I've tried it. I've tried your way." And yeah, that is so much faster, but it doesn't necessarily work in every vehicle, and it doesn't necessarily yield the specific detailed results that I'm looking for, like what I would hear in a competition car with a very focus point center on a one-seat tune. Still probably better than what 95% of most new customers have ever experienced, and people probably be happy, but it doesn't, once again, it doesn't take necessarily the environment into consideration or the effects it has during this process. And it does not teach the person tuning how it works, if it's working, or how to correct the issue at the end if it's not correct. It's still a good solution for a lot of people, but it doesn't yield the detailed results, which is kind of what we're here to talk about. By ear. Yes, openly, this is the slowest initial learning curve because you have to practice this. Once it's learned, you could be as fast as the tape measure. You could be as fast as some auto-tune DSPs out there. It really depends on your experience level. A lot of our competitors that use this process, and a lot of the guys overseas that have been taught this process, literally are doing some cars in less than 10 minutes, and they're spot on by the time they get done. It typically, as long as there's no mistakes made in the process, yields extremely accurate results. It also allows your ears to hear things as it is physically happening, teaching you how the process works and giving you the ear to button to knowledge ability to understand how to fix issues if any other processes fail. And it allows you to greatly excel in being able to deliver that ultimate listening experience to the person who has to listen to this system in the end. Now, phase versus delay. So what we're doing here is we have 6 speakers in this car, and ultimately, if we play a single, like full range stereo pink noise phase pulse, we would want everything to sound like it comes from the center of the vehicle in one spot. In that, not necessarily should we be hearing everything coming from the left or the right side. But in the end, if you have everything set correctly, left and right are verified, and we have everything in place as far as we've done our delays and our phases, you should be hearing a center image with additional locations, left of center, right of center, and then left and right, or is what people used to call it, the 7 drum beats. You should be able to accurately hear the recording as it was recorded, and as well as having proper placement of those instruments and the vocals in the system. Now, yes, I know there's at least one person on here that's sitting there scratching his head, where's the rest of the information? Do keep in mind reflections, interior acoustics, all that stuff will have effects on the accuracy of this. If you're dealing with a lot of reflective energy, that will create multiple points of referencing and actually cause it to smear a little bit. And unfortunately, that is going to be a vehicle by vehicle thing that you cannot fix without dealing with those reflections in the car. And of course, you have speakers that are down low and you have speakers that are up high. So we need to make everything sound like it's coming from up top. So number one thing here, a lot of people, if you're doing the tape measure, just remember, a lot of people always assume that the subwoofer is the farthest speaker. You might want to measure it. In a lot of vehicles, it is not. In some cases, you will find that maybe even something over on your passenger side is actually further away than what that subwoofer is. Select your listening materials for this process. So what we use here is we use a stereo pink noise track. We use a detailed and very well isolated batch of vocal tracks. It's female vocals for high frequency and mid-range, male vocals for high, mid, and low mid-range frequencies, and low male vocals for lower mid-range and mid-bass. And then we've got a whole series of other tracks. This is just, like I said, this is not an ARC CD. This is something I put together and it's worked out well. So I'll be giving you that list here in a minute, and we'll be using that as a reference on what tracks we use throughout the entire process. But you want to have a plethora of tracks, whether it's CD, reference recordings, digital media player, whatever your source media is capable of handling, and get that put in place. And please, iTunes in general is not a reference source. Don't use it. Okay, so this is my setup disc. Bass pulse test track on track 1, stereo pink noise. My female reference vocal for during delay is Ballad of the Runaway Horse by Jennifer Warnes. Softly and Tenderly for Johnny Cash is the mid-range frequencies. These Bones is my mid-bass track. For verification, especially going right out of mid-bass, which we're going to go through that process here, we have Nora Jones, Cold Cold Heart, John Campbell, Down in the Hole. For sub-bass, we have Patricia Barber, like JT, and Nitty Gritty Dirt Band, Will the Circle Be Unbroken, and of course we have a couple other tracks on there for overall listening. I could pretty much set up an entire system with this entire disc, and it's a great reference point. We'll post up this information later on so everybody has it as a reference if they want to go out and acquire the tracks and use it as a reference towards this tuning process. So use your ears. How to know if it's out of phase. If it lacks frequency between left and right drivers, especially in mid-bass, or even mid-range drivers, it's out of phase. Phase adjustments between groups of speakers, tweeters and mids and mid-bass, they can significantly change the location of where you hear the sound coming from. A very common one is if you're running like a two-way speaker system, or even in the three-way, if you flip the phase on your mid-bass drivers, you can hear the sound jump up to the top of the stage or somewhere near the top of the stage, and it can be refined with signal delay, which we're going to go over here in a minute. Or you can hear it coming to where the stage sounds like it's really tall because you got low frequencies coming from the floor of the car or out of the door panels, and the higher frequencies coming from up in top of the dash where the A-pillars are. So how does this process work? So first thing we're going to do is we're going to put in the phase pulse test track. And we're going to mute all the speakers in the system except for the tweeters. And what we're going to do is we're going to go to that left front tweeter, and we are going to adjust that left front tweeter because it's closer than the right tweeter, and we're going to increase the delay on it. And I suggest you do this with your eyes closed. Find it, make sure you're highlighted, get your finger on the keyboard for that adjustment. Use your eyes closed and listen to, you can physically hear the two speakers come together in the center. Now, one practice that I always tell people is go past that part. And after you go past that, past where you think it's center, you'll hear it diffuse again. And this is something that gives you a reference of being able to know, know how your system is doing, where center is. Because sometimes people get a little premature and they will actually stop adjusting even before they actually should. Now, there is phase pulse test meters out there too that you can use. You can use meters to verify phase. I still encourage doing it by ear so you can understand and hear what delay is doing. So once you get the tweeters put in place, now you're going to go ahead and you're going to listen to track 3, which is the Jennifer Warnes track, and you listen to just the female vocals. Some people may have troubles with this depending on the crossover frequency, so you can lower the crossover point temporarily so you get a little bit more vocal in, and you can play with it still and get it buttoned up in the center to where it's pretty close. And then what we're going to do is we're going to go ahead and unmute the mid-ranges, and we're going to mute the tweeters. And now we're going to do the same thing with just the mid-ranges on the front of this car until they come, you physically hear them come to the center of the vehicle. Now, yes, is this the scientific way of doing it? No, this is the simplified way of doing it to teach and educate and let your ears learn a little bit more about what's going on in the process. And then once you get it where you think you have it in the center, always remember to go past center point and then come back so that way you can hear the parameters of where the center of the vehicle is. Listen to tracks 3 and 4, the female vocal, as well as also the male vocal, the softly and tenderly song. And then we're going to go ahead and work on the mid-bass drivers. Now, a lot of people have a habit of not doing this with mid-bass drivers, and as a result, you can get into a car and in a lot of cases hear information being pulled off to the left and right, especially in things like lower end instruments, as well as also low vocals. So if you have to increase the low pass crossover, which will let more higher frequencies come in, so you can more easily hear the information come through it, do the phase pulse, get it close to the center, like we talked about with the previous ones. And then at that point, use the musical tracks, which in this case, you could use the Johnny Cash song, or you can use the King Singer's Softly and Tenderly song. Or I'm sorry, the Softly and Tenderly song or the King Singer's song with the really low male vocals in order to isolate how that is positioned in the vehicle. Or if you've crossed them over high enough, you can actually use just the mid-range frequencies as well. Use a selection of music that works best for you to find that center point in the vehicle. And like I say, listen to tracks 5 and 6. Track 6 is the other Nora Jones track, and it's also great for listening to those male vocals. Now we've got this, but the problem is here is if you look, all we've done is we've been able to bring left and right together in center to create an arrival time at your ears at the same point between left and right. But in a lot of cases, we still have a huge or very tall stage. It still sounds like your tweeters and mids are coming from up on top of the dash. And then you have the mid-bass drivers coming from the floor or the bottom of the doors. So we have to get these buckled up now. Now, one thing, and I'll show you this here at the end, is grouping. And the output panel, the delay panel, they all have grouping capabilities. So at this point, you're going to want to group your tweeters together. So you make them both group 1. You would group both your mid-ranges together on group 2 or 3, whatever you want to do. Just make sure that both mid-ranges are the same number, and same thing with your mid-bass drivers. What this does is as you make an adjustment on one speaker, it's going to make adjustments on the other speaker that's in that group at the same time. So you're going to mute your mid-bass drivers and leave only your mid-range and your tweeters. Now, in this case, the tweeters are farther away from the listener than the mid-range. So we're going to want to delay the information on the mid-range so that way it sounds like one physical pulse, not two. Right now, if you listen to it, it would sound kind of like da-da, like really quick. And what we wanted to do is we want to have all the mid-ranges and the tweeters sounding like one pulse coming from the vehicle. So it'd be like da, even though at this point we have 4 speakers playing. So what we're going to do is we're going to increase the delay on the mid-range speaker. And we're going to do this with the phase pulse, or we can do it with tracks 3 and 4, female and mid-range vocals. And you should start to hear it sound like a single voice. And then group the mid-bass drivers, and you're going to end up doing the same thing. At this point, you can flip them in and out of phase 180 degrees, and you can check that first to make sure that you see if they're going to jump or even put itself in the right position, or you can use the signal delay to do the same process. Every vehicle is going to be different. There is no textbook process for this. You're sitting there going, this sounds like a lot of work, but I guarantee once you have done this a few times, like most installers who have done this process, they're going to say, wow, that makes sense. This is easy to understand. They practice it, they become proficient at it, and as a result, it becomes very easy for them to use as their reference point for setting delays. And of course, last but not least, subs. So right now we have literally everything sounding like it's coming from up front and the top of the dash, but we still have our subs coming from the back. And one of the issues with this is, like we said, sometimes the sub is not the furthest away, but we're going to start with playing with phase and delay on the sub. So we're going to start with phase, and simply we take, I like using track 9, which is the Patricia Barber Like JT song. It starts off with this kick bass drum that's actually recorded out in the distance behind the band from a single microphone at the back of the stage. So it becomes very easy for you to be able to tell if you are getting sub bass from the back of the car or the front of the vehicle. So if you flip the phase on it, you'll hear the sub actually either jump up to the front of the car, or maybe it will make it worse, depending on where and how it's working within the vehicle. Use your ears, teach your ears to recognize the difference, because otherwise things like tape measures and auto-tune might get you pretty close, but it's not going to teach you how to fix it if those processes fail. Then, of course, we start by doing what speaker is further away. So in this case, if the subwoofer is the one furthest away, flip the phase. If the subwoofer is not the furthest away, still flip the phase on the subwoofer, adjust the delay, listen to see if it's going up to the front of the car. If the subwoofer is the farthest away and you're hearing the information and you can't correct it that way, then group all your mids and highs together and increase the delay there. Just remember, whatever speaker is farthest ultimately ends up reigning supreme here in setting delay and phase. So just to recap, if the subwoofer is farthest away, increase the delay on your mids, highs, and tweets. Check phase, acoustical phase, by flipping it 180 degrees in the software first on the sub before you do this. But if you're like, say, your mid-bass driver or your mid-range on your passenger side is farther away than what the sub is, then do everything with the sub itself versus the mid, high, and tweet. So basically, you can hear the thing jump around just like that. And like we just talked about, you can actually delay it and get everything up to the front. Track 7, Nora Jones' Cold Cold Heart, is also a great track if you don't want to use phase pulse, which is very difficult for low frequency. But the Cold Cold Heart is a great track for helping locate as well, or doing a secondary verification to make sure your sub bass is up in the front. Moving on to the EQ. Now, at this point, we have not 100% locked in ability to have a focus point. And don't think that just setting delay, you're going to have this tiny little bullet point source up at the dash, because you have a lot of things going on with an equalization up at the, with your mids and highs that are going to give you a different product, meaning a different sound at the driver's position. This is where we need to use the right product for the right tools. So some tools we recommend, the Audio Control DMRTA. Been using it for a while, great piece. Audio Control 3052, 3055, or 3056. Old school, a lot of people still use them. They're reliable, they're big and heavy, so if you're traveling around a lot, but they're a great item. And of course, then True RTA. If you do become proficient, they do have options for 1/6, 1/12, and 1/24 octave RTAs. Options for advanced tuning, which we're definitely not getting into this as far as that level. What our focus today is going to be 1/3 octave RTA, which is kind of the reference platform for the Audio Control RTA pieces. So the process for the correction. The initial part of tuning this system is not to tune the system itself, it's actually to correct the acoustics of the environment, the active environment, to a correct level to where you can tune. Never think that this part is actually tuning the system. This is correcting the acoustical platform or the acoustical response of the vehicle itself. Rule number 2, this isn't rocket science. It's unnecessary to do anything finer in most cases than 2 dB per step. I say that because the True RTA, as well as the Audio Control 3055, 3056, and so on, they all have the options to be 1 dB per step. If you're doing a competition system or a real high-end reference system, yes, go ahead and do those higher resolutions. But 2 dB per step is more than sufficient for 99% of the systems out there. And rule number 3, speed sampling with the RTA. I literally had a guy who said he had his RTA set up at the fastest speed because it made it easier and more enjoyable to tune with the lines dancing much faster. Real simple, slow it down. It'll take an average over a few seconds time, depending on your sample rate, and it'll prevent you from chasing things that just simply don't exist. So when we look at a system and we're looking at a frequency response, this could be an example of one system that you're looking at the overall reference of what that response in that vehicle is. If I was hooking up a system and based off crossover points, if I looked at this RTA right now, the first thing I would be doing is making sure that my tweeters were hooked up or even turned on, because at a 5500 hertz crossover, there's very little information beyond that. But some people say, well, what do we want? Do we want a flat response? No, we don't want this. If you're competing for RTA in a competition, then yeah, go for it. This is like the RTA competitor's dream of having a flat response and getting a maximum score. But this is something we don't want. It's typically going to sound stale, not have any body in the vocals or in lower instrumentation, and there's no bottom end whatsoever. Now, this is an example of a reference curve. This happens to be one of the reference curves I use for doing competition vehicles. And as you see, it's not flat. I have a kind of a key reference point of about 5K to 5500 and up to 10K range. I'll go usually about 3 to 4 dB up progressively. And then I'll also go from about 400 hertz up to the 125. I'll go typically about 6 dB up from there progressively. And then the sub bass, it's usually flat out to about 50, from about 100 to 125 down to 50. And then it'll start progressing up. Now, this does not represent a final product, mainly because sub bass can escalate significantly above that, depending on how much you want or how much impact, how much impact you want to have on there. So how do we do it? Here we go. So in this case, we have all of our speakers in the system, and we need to focus on remembering where our crossover points are. I probably should have put a slide in here to reiterate where we were with the crossover points before. So our tweeters are basically 5500 and up. Our mid-ranges are from about 51, 5250 down to I think it's about 175 hertz in this one. Our mid-bass drivers are 165 down to 60, 65 range, and then our subs are below that. You have to think about the entire frequency spectrum and chop it up in pieces. So here's what we're going to do. We're going to mute everything except for the front left tweeter. Now we remember our messed up frequency response in the vehicle here. What we need to do is we need to start focusing and correcting it. So what we're going to do is we're going to ignore the majority of this frequency response display here, and we're only going to focus on the 5K region. So we're going to block all that out, and this is all we're focusing on right now is 5K to 20K. And we're going to adjust only the front left tweeter until we achieve what our target curve is on that one speaker. So picture that and remember that for a minute. That's just the left front tweeter. Now we're going to come in after we've achieved that, adjusting in the EQ. And just remember, if you have the opportunity, cutting is always better than boosting, especially in tweeters. If you boost too much, you do have the ability to introduce noise on certain systems. The other thing to remember is, none of us are farm animals or dogs that have super intelligent hearing. You can't really hear much. Most people can't hear with a squad over 15K. Don't sit there and try to really boost the daylights out of 20K, 15K region. Because that's where you're going to introduce a lot of the noise. Most people can start letting things roll off past 12K, and if it rolls off naturally, let it go. So now we're going to basically mute the entire system except for the right tweeter. Now, if you remember, this is now what the right channel side system would look like. We're going to isolate that. And this is what our left side looks like after EQ. Now, what we want to do is we want to match the right channel tweeter to exactly down to the dB, or within what the parameters of the meter is. We want to have this dB, or this set, from right channel to left channel match. So adjust your right channel tweeter to match your left channel tweeter. And there we go. To the driver's position, we have an identical reference response to the driver for the tweeters now. Now we're going to mute all the speakers except for the left mid-range. Now, let me back up here one screen here. If you look on here, you're going to see that there, at the low frequency at about 5K, is right around It's too small on that screen here. On the dB markings, it's just a hair below 85 dB. This is a reference point that you're going to want to remember because this is where you're going to set your mid-range. So now we're going to unmute the mid. Here's our response chart again. And now we're going to isolate the frequencies that mid-range is playing. Now what you're going to want to do is you're going to want to make your reference line match that just below 85 dB mark that the tweeter ends off at 5K. So once we adjust it, it's going to look like this. So now we have a pretty much flat response all the way down to just below 400 hertz, or just below 500 hertz, right around 415, 430. And now we start to increase the amplitude of those frequencies going up in the mid-bass driver. Now this area here in the low end, down where you see the 200 mark, this is where you get a lot of the throatiness of the male voice. You get a lot of the vocals of the lower body end of different things, including instruments. You're going to get different things like the throatiness of the male vocal that you find, like you listen to Dire Straits, the lead singer, he's got a lot of songs. If it's real thin and he doesn't sound real bodied, you probably need to increase frequencies around 250 up to 400. It's usually around 315, 400, but sometimes it's around 200 and 215. Just little key facts. You're going to learn more. We're going to have a cheat sheet for you here in a little bit too that you can see as well for key frequencies. Now we are going to move on just like we did before on the tweeters, and we're going to mute the left mid and unmute the right mid. And of course, here's our response. We're going to isolate the frequencies for what we're visually seeing. This is the crossover range of that mid-range driver. We're going to reference back to our left channel that we've already EQ'd. And now we're going to EQ the right-hand side as well. And that right-hand side driver now matches the left-hand driver. Now, why are we doing this? We're doing this because you don't want certain frequencies to be louder out of one speaker than you do the other speaker. If you've ever sat down in a higher-end installation and you're listening to a high-end car and you listen to like a real detailed jazz track, and the problem which sometimes happens in systems is at a moderate level, it will be it'll be one of those things where all of a sudden the vocalist starts getting louder, and she goes from the center of the car and starts pulling off to the left-hand side of the car or the right-hand side of the car. Or maybe it's not just the shift of the stage, the whole presence of her voice gets bigger position-wise because there's maybe distortion or there's a peak in a frequency on one side that's not on the other. We're correcting that to the driver's position right now. And like I said, we're only focusing on a single seat tune right now in order to make sure that we're not getting people complicated with how to do two seats. So we've already done left-right thing. All we're doing right now is EQ. So we're going to mute the mid-range, and now we're going to go down and do this to the mids. Once again, we isolate the operating frequency of that mid-bass driver. We flatten it out based upon the curve that we want. And this should roll continuously off of the mid-range drivers. Now we're going to mute that left mid-bass driver and mute the right mid-bass driver. Here's our full spectrum. We're going to isolate just this one side. And once we go to that one side, we're going to go ahead and match that to the left, which this is our left side post EQ. And now we have left and right sides matched. This is a critical component in tuning a system because if you don't do this, you're going to have unwanted artifacts all over the place with the way a system performs. And then last but not least, the sub. Now the sub, I do this with all the speakers unmuted. And the subs, use the RTAs only for the purpose of getting rid of big peaks in the system. If you see a huge peak in the system, like say around 40 hertz, which is a very common area, drop it down. One thing you are going to notice is if you're trying to do a sound quality system, you are going to want to balance out the response and the curve that you see on the RTA and the low frequency. But if you're doing a street system or something where you want to have a much larger, much louder subwoofer presence, you may not want to do that. 40 hertz to 60 hertz in that range is usually where the resonant frequency of a vehicle is. And if you bring that down, some street system guys are going to say, hey, I need more bass. Leave those up. This is where you have to tune for the customer. If you're doing an SQ system, definitely smoothen it out. All right. And of course, when we look at it, make sure you adjust the subwoofers. If you have more than one on more channels, make sure that you actually tune them at the same process at the same time. In this case, we adjusted them out. Make sure that you adjust them at the same time to prevent cancellation between each other at that low of a frequency. But at this point, you can start tuning for the customer. Now, this is one that's kind of a killer for some people, is more delay. After you EQ the system and you have basically tonally matched and corrected left and right sides, you may notice that things are more defined tonally, but now you may hear some small issues in what you did with the delay. You can go back to listen to track 3, 4, and 5, the female track, the male track, and the real low male vocal track, and just do a re-verification. You might find that you're doing just tiny little tweaks, but you don't want to do any real major tweaks, because if you do major tweaks, you can affect your delay and your phase at a later time. Usually it's just going to be very small adjustments at this point, but you can do it to really button up that stage and give you that presence where you let your friend get in your car, and even though you got no center channel speaker, people think you have a center channel speaker hanging right there from your rearview mirror. So repeat the same process using the phase pulse or the vocal tracks. That's totally up to you. And learn from the changes you hear with your own ears. Have a better understanding of how and why these changes have the effects that they do. This is where practice comes in, because the more you educate yourself in process, and the more you educate yourself in this process, the easier it's going to be, even if you use other processes, to understand how and why. And honestly, the benefits to knowing what happens when it does this stuff, whether it's a tape measure or pushing a button on a keyboard, and letting your ears and your brain work together so you can hear that stage move around, and most importantly, fix it if those other processes don't fail. The benefits here: tighter focus, better imaging, and better customer service. And for the people who are doing their own tuning, just a better experience. So the next step, and this one isn't necessarily as much of an issue anymore, but it's still out there in some processors. Save your settings. It's a computer. You literally have as many options for saving your settings as you do hard drive space. Nothing worse than getting all the way into a project and something happening and losing everything that you just did. If you save it in multiple sections. Whenever I tune the system, I save it in 3 sections. After crossovers and basic level setting, I call this a safety setting. That way, anything I do, the speakers have protection from frequencies. I also do one after I do delays. And in some cars, if I have time, I'll do the delay. I'll redo the delays multiple times just to test myself to make sure and check on my consistency. And then also save one after you've completed the EQ adjustment, doing acoustical correction in the vehicle. Now, tuning 101, this is some basics here. A couple things in here. There's a few people out there that might shake their heads on this one. A lot of people, it'll make sense. And get to know real instruments. Some to correcting the acoustical response or environment of the vehicle. It's always good to know what real instruments sound like, so you can help identify those instruments and start to figure out where a mistake might have happened frequency-wise. If you hear an instrument that doesn't sound right, then at that point, what you want to do is you can go to this chart. This is readily available on the internet. It's a great reference that shows you everything from the operating spectrum or operating frequencies for different instruments, as well as the key acoustical frequencies, as well as the harmonics that can be. It shows you the possible range. Some of the ones that usually kind of makes people shake their head is some of the upper frequency instruments, like cymbals, being able to go all the way down to 200 hertz. These are things to remember when you are tuning a system and learning what some of these instruments sound like in real life, and not through another system or not another amplifier or not another not another processor, just basically saying like through a system at a concert or something like that. It's always great to have that reference. And then become familiar with those key frequencies. That way, your final product will come faster and quicker, and you can start to learn all these little things when you're starting to do the tuning for the customer. And most importantly, for dealers, qualify the customer. When you have a customer that walks into the door, learn about them. Find out what kind of music they listen to. Ask them what kind of media they play it off of. Is it a CD? Are they listening to AM/FM radio? Are they listening to 8-track? Whatever. Find out what they're using for this for producing the content and the source. And if possible, it's always best to have the customer's source in your hand when you tune the system. And of course, make the final adjustments for the person who is listening to it, knowing that way they fall in love with the system that was tuned for them. If you're the tuner, obviously, tune it for how you like it. Don't tune it for how I like it or anybody else. You're the one that has to listen to it. Sound is subjective. Only the person listening to it knows if it's right or wrong for them. Now, tuning and listening, understanding instruments and looking at the actual sounds of the instruments, instrument versus frequency spectrum, getting to know the live instruments. But there's also this point of responsible listening and tuning. I can't tell you how many times I've gotten a tech phone call talking to somebody about tuning, and they've been in a car for 3+ hours. Their ears are shot at this point. Here's a couple, give you an idea of OSHA, who is extremely conservative, but they say over an 8-hour day, don't listen to anything over 90 dB. Honestly, my general rule is if I'm tuning a car, I will listen to a car between the 80 to 90 dB mark doing phase pulse. And when I start tuning, I'll stay in there for maybe a maximum of 15 to 30 minutes. But usually if I'm getting closer to the 30-minute mark, I'm getting out of the car and giving my ears a break, especially if I'm doing some critical tuning. Listen responsibly. 15 to 20 minutes is a good marker to remember. Use a wide genre of music. Don't tune the system specifically for jazz and classical for somebody who's listening to heavy metal and rock, at the risk that they're going to fire up their music and it's going to sound horrible if it hasn't been tuned well. And like I said, use the music from the customer for final touches. This one, I only put this in here simply because the fact that there's a misinterpretation of what people seem to think about instruments, and some people online seem to think differently. Is knowing how an instrument sounds necessary to tune? The answer is no. But when you have the goal of using the DSP, which is use the available resources and the available product to a level that is closer equal to what the engineer and the artist intended for the original recording to sound like. That's great if you want it to sound like the engineer wants it. But the idea is you can use this reference, and this is a goal to correct the sound, to get yourself to a point where you can tune it and make the tweaks that you like for the way you listen to music. After restoring the sound in the vehicle to an equal level of the original recording, use the same resources in the DSP, equalizer, even delay for some people, to tune it for where that person is going to listen to it. And always, if you are not the person who has to listen to this and you're the person tuning it for somebody else, tune it to their liking, not yours. Learning how the instruments does help increase your proficiency and knowing where to make adjustments when needed for those final tuning processes, but it is not necessary to correct the environment with the steps we went over. And simply follow the process, and creating reference curves does not necessarily mean the system is perfectly tuned, but it is a starting point that you become familiar with, and you can, at that point, get into almost any car and tune from that for the customer. So we already went over that, and just here's a couple little cheats here. Bass guitar, bottom at 50. I'm not going to go through all these, but here's different things like hi-hat and cymbals. The clang of a cymbal is at 200 hertz, but the sparkle is at 8 to 10K. Organ. These are all quick sheet bits of information in order to be able to allow you to say, hey, I wish it had a little bit more of this. You can use this information in order to use as quick references for different things. The sibilance in a voice usually starts at 5K and goes up to about 10K. Some female singers, you're going to find it up around 10 and 12, and then you have the air of the system, or the openness of the system, which is usually affected between that 10 to 15K mark, which not every user can hear. So This here is an example of one system that was tuned actually for a competition level, and you see this has got some post tuning in it. It's got a little bit more of a bump around 10K. It's got a slight bump around 1K. In fact, this actual curve went to win nationals several years ago. That's how old the screenshot is. But we got the key points here that have been focused on, and everything else follows that reference curve still. So, any questions? If you have any questions, if you know how to use Zoom, put your hand up. Otherwise,
we did have one question from Andy asking how the RTA was picking up the sound. Was it electronically? Was it acoustically? Maybe you can go a little bit more in detail about that setup.
So for the RTA, the microphone is typically placed, for some people, they'll use microphone stands. I use, believe it or not, I haven't used a microphone stand in years because I typically will put the microphone to where the tip of the microphone is relative to the center of the area between where my ears are in the vehicle. So the microphone hooked up to the RTA is measuring basically measuring the adjustments in real time as I do it, as well as they're measuring the acoustical response. Now, I do not use, like in the case of like True RTA or even like an audio control 35, 55, 56, and so on. I do not use the generators for it because at the end of the day, the frequency response between devices can change. And if you have a device like a source unit or you're playing CDs, that could actually offer a different frequency responsive signal than, say, the generator that is built into this test equipment. You can use the ones in the test equipment as a reference point if you'd like, but the risk of having a different result after you get everything done is very high. I've had that before. The ARC Audio boat that we had, actually, we were using an onboard computer on it, and we were doing that didn't have a tone generator in it at the time. There wasn't a lot of options for media, so we were using a generator built into the RTA. Of course, we would tune the system, and then we'd hook everything up to the computer, and then it was like, this doesn't sound right. And that was because we want to make sure that we're using the actual source to generate the signal for the system, and then let the RTA simply analyze what is going on in the vehicle, and then use the visual cues from the RTA as the way to know where to make those adjustments. Anybody else? Okay, let's shut this off here, and we're going to go into the software here, and I can answer any questions we've got. Trying to make this as painless as possible for you guys.
Do you have a question from Neil?
Yes, Neil. Let's see here. Can you provide a reference sheet illustrating the curve? Yes, I can. I will have to generate it and post it up for you guys. That'll take a little bit. That'll take a little bit more to get up. So, all right. Let me get the software started up here. All right, so this is my desk system here, and just going to kind of go over a few things through the system. Some of you will probably notice a few things in here, and we'll address a couple of those while we're doing here. Let's see what's showing. Okay. So the software is pretty intuitive. If you've used any other processors out there, the software is very cut and dry as far as the options it gives, but we have a lot of extended options too, especially when it comes into the OEM integration standpoint. In this case, my desk system is actually, it's hooked up to a 5-channel amplifier running mids and tweets, and then I've got a sub on the floor down behind me, so it's hooked up to a X2 1100.5, and it's running off of the computer as the source. So we talk about the starting of the setup process. One of the first things, of course, is you're going to come up here to the firmware tab up here in the top position, and this is what this screen looks like. Now, If you're looking at the version numbers, I'm going to explain. We are doing a lot of testing right now for a upcoming firmware software release. So we are incrementally increasing versions as we're doing additional testing for bugs, verification of the system working right, and adding new features. Yeah, that just probably raised a couple eyebrows on a few people. Some people might have already seen a few things, but we're going to get there shortly. So we will have new updates for the PSC. We're going to have new updates for the firmware and software. These numbers, if you look here, we have the version. And the version itself is what is currently installed on the processor. And then we have what's on the cloud. The cloud is what all of you use for ongoing testing, updating, and everything else here. So in this case, you see I'm above the cloud version here. But I want to give you an idea here, and this is set up right now. If you look how it says update on the PSC, my PSC version does not match what is on the cloud, and as a result, it says in red, I need to update. So if you're going into the firmware panel and you see any of these red, you need to update these. In the case of the current version 5.8, yes, there is a bug on the PSC one. That's even though you've updated it, it still shows that it has been fixed. It'll be in the next release. But you start from the top down. If all of these are red, you start with the top one here and work your way. In most cases, if you update the desktop software, when you start it up the next, it'll automatically queue you in order to update the firmware on your processor. This is really important because what this does is it makes sure that your computer is communicating correctly with the processor, and most importantly, that as you make adjustments, those adjustments are exactly what you are asking it to do. If you set your crossover to 200 hertz, you want to make sure it's actually sending the command to go to 200 hertz. This is where updates are extremely important. Also, if you do run into another issue, we also have up here, which is email support info. If you click on it, it actually pops up a window right here. You put your name, your email address, and you put a description of what your issue is. Or, hey, if you got a feature request, you can put it in here too. When you send this to us, you have to be connected to the internet, and this will actually send us everything from your settings file, all the settings in your K2 processor memory, as well as the serial number, IP gateway address. We're not getting credit card information or anything like that, but if you do want to volunteer it, we'll take it. Everybody would. But we're making sure that we have all the information we need to help you diagnose the problem that you may be experiencing. And in most cases, it can be identified, fixed, solved, and resolved simply by here. Or maybe you're one of the lucky ones that found a bug that our entire test team didn't find. This is some of the information that will help us replicate the problem. And if you know exactly how the problem happened, in the description panel here, try to include information that will allow us to actually allow us to actually reproduce it. Because if we can't reproduce it, it's very difficult to fix. The question on where we get the phase pulse test tracks. If you go to our website, and I'm trying to remember, I can't link out of it right now with this. If you go to support on our website, under the support tab, there is a tab, there's a sub tab on there, and I forget what it's called, but it's available on our website. We have full range pink noise, mono and stereo. We also have the pulse test tracks. That is all available for download in high res, as well as standard resolution in multiple formats.
Under support, it's under Tech Talk.
There you go, under Tech Talk. So first you go to firmware, you do your update. Then we're going to go into setup. And once you're in setup, like we said, name your output labels. This is what's going to your amplifiers and what speakers are connected. Integration mixer input labels. This is your input into the processor from your source. Yeah, integration mixer output labels. Some people do get a little confused on this one. If you come up here to Open Mixer Assistant and you click on it, this gives you an illustration of how the two mixers in the processor work. You have input mixer or integration input mixer, and then you have the output mixer. Now, I'll show you the standard mixer panel here in a minute, but if you follow this, here is your input mixer labels. Here is your output mixer labels, which you don't necessarily, or I'm sorry, your integration mixer output labels, which you don't necessarily see. And then this is your output labels right here. And so as you change the names on them, this is where you're going to see all the names changing on this system. So you can use this as a reference. And we'll come back to the output mixer here in a minute. You can also change the colors of the text as it's illustrated in the system. We also have, if you're running the PS8 Pro, even the IPS 8.8, this will change depending what product you're into, but anything that has one of the illuminated displays, you can change the colors on it. Even the ARC series amplifiers, you can use this software by itself to actually change the color of the logo on the ARC series amplifiers, even if it doesn't have the IPS 8.8 in it. Over here on the other side, you've got options. These are the turn on and off delay circuits that we talked about earlier. 12-volt preset switch. If you don't have a controller or you're not using the IDATA piece and you want to be able to have presets, you can simply do the presets by putting a toggle switch or a multi-position toggle switch that latches to ground or positive, and follow the diagram that's available on the product page. And if you want to send positive trigger signal, you just simply click on the checkbox and that turns it into a positive trigger signal switch. If you're doing ground, leave it unchecked. If you have the PSC and you don't want to see that warning label pop up every single time, disable the PSC driving warning. Disable confirmations. Confirmations, see that how it pops up and gives you a little description of what it is. You can disable the confirmations, including the ones that have all the okay, are you sure you want to do this, things like that. Enable Wi-Fi. We do have the Wi-Fi chips and we are finishing the apps. But if you do have a computer that is Wi-Fi capable, you can get the Wi-Fi APX chip and actually do all your adjustments wirelessly on the computer. And coming soon, we'll have both Apple and iOS and Android apps as well for you to be able to control the tuning functions, not the setup functions, because there's still a setup for the Wi-Fi, but you can control all the tuning functions via your phone, tablet, your whatever you got as far as a wireless device. If you're hooked up in the Maestro, you should always see this checkbox checked right here, Maestro mode. It usually religiously always checks, but if for some reason that's not communicating, always make sure that checkbox is checked. And then PSC volume saved on restart. This is if you are using the PSC and you adjust the volume and you don't want the system coming back up to a predefined setting, you can actually check that checkbox and it will come back up. The system will come back up exactly where it left off, and then PSC password. We also have spit up auto select. So for the guys that are running digital and analog, if you're running an aftermarket radio, for example, what you do is you do multiple presets. So say preset 1 is your analog input for the analog output of the radio. You set that up and define it as preset 1. And then you would come down here and say save to preset 2. And when you're on preset 2, when you're on preset 1, you come over here and on digital detect. So when it sees the digital selection from a digital media device or a CD player, you want it to switch to preset 2. And then if you have it on digital loss, go back to preset 1 or vice versa. What this does is when it detects the signal, as long as you have this down here checked, enable auto select, when it sees that digital signal, it will change over to, after this many seconds, whatever you have defined in here, it'll change over to that digital input, or after it loses the signal for that many seconds, it'll switch back to the analog preset, which is analog input and also analog sound. We also have navigation ducking. We have some people overseas that are wanting to do things like OEM systems with reference aftermarket sourcing. You say you're playing your portable high-resolution media player into the digital input, and you get a phone call. What you can do is you can set it up on a preset. Let's say we're on preset 3, like we are right now, indicated down here on the bottom by the illuminated recall button. And we're on our digital media player. And we have analog coming from the OEM radio on channels 1 and 2. So if I have this set up and this is enabled, what will happen is if I have a navigation prompt come in on channels 1 and 2, it will detect that signal and it will switch over and attenuate my digital media player to where I can get my cell phone command prompts as well as all my navigation prompt commands. You could also adjust this to other levels. to where it completely mutes the circuit, and you can simply use that as, say, the other way around. If I'm on audio, but I plug in my digital media player on SPDIF, and I have SPDIF selected, then it'll select automatically, it'll go over to that digital media player. There's a massive level of different opportunities for integration. And of course, if you are processing a digital sound or a digital source, we'll display the sample rate here as well too. As well as we got meters here, not necessarily critical. Some people freak out about temperatures. The temperatures are going to get warm because the temperatures are from within some of the electronic components. Nothing that anybody has to worry about. We also have the output panel. This is where we start talking about, we have the advanced mixer, which is the second mixer that we showed. Come back up here. This is up here. Most people are never going to touch this. You really don't need to focus on this one. You can actually disable it by coming down here and unchecking advanced mixer. And if you notice, the tab goes away. We got delay, and we got 31 band PEQ. Right now, this is a parametric EQ, and we can manually adjust all the individual channels one by one or all together. You can also adjust all of them together, then do one by one and come back without losing your previous setting. The exception to that, of course, is unless you have different bands that are like one band that has different frequencies on each channel. If you don't want parametric, you simply come up here and click on the parametric, and you notice you lose a whole bunch of controls because now it is a traditional, simple 31 band EQ. And then, of course, you can add that back in by clicking parametric. Outputs. This is, if you're doing the Maestro module, this is one of the first steps also that you have to go in and touch. If you're doing any of the Maestro AR modules, you have to come in here and tell the system what your channel assignment is, because it has to know what your channel assignment is. That way your OEM fader and your OEM sub-level controls and stuff like that all know how to work. If you assign these here, front left, front right, rear right, center base, you can select any one of these, and as long as you adjust them correctly and select the right one, your OEM controls through the PSC also needs this, but the PSC or your OEM radio through the IDATA AR module will allow front, left, left, right, front, rear, center, and base to function correctly. This is the grouping that I was talking about earlier. So if I want these two channels to adjust at the same time, we simply come in here and click on group, and now when we adjust this, if you see we're adjusting these now, or I can come in, I can actually just ungroup this way, and now I'm adjusting one at a time. Put that back there. Then, moving forward on there, we also have tone controls. This is basically where you, if you're using the Maestro module, you can reprogram how those tone controls on your radio works. So you have high frequency shelving. You can actually set the frequency here, as well as the amount of gain that you want that control to work and the slope that it affects. So you can customize this for the system and the limits of what the system is actually going to allow you to actually have tonal controls. You could also literally, depending on how you set your AR module up, this low frequency control or shelving control can turn into a sub-level control directly from your OEM head unit. The remote, if you're doing the AR module, you can actually redefine the minimum and maximum master volume range of the system, as well as the minimum maximum volume range of how the AR module adjusts the volume in the system. This can actually protect the vehicle from going up too loud and blowing up speakers. And then we have the remote configuration for the LR1, which is the single knob remote control on the left-hand side. You can actually check all your channels complete and leave it set at -99 on remote minimum, remote maximum, and now you have a volume control. Or you can assign it just for, say, the sub-channels, and you can just click on those, and now you have a sub-level control. Sky's the limit. It's complete open architecture for how you want to actually be able to do the system. Delay and phase. Remember we talked about the labels. Everything's here. You can also change the name in here if you want to. Phase is taken care of simply by checking the check boxes below this area here. And then if you have the grouping, this is where you can do your grouping. We talked about when you want to vertically align the speakers in the system. You can adjust these to where you can adjust one by themselves, or if you select them together, you can adjust both of them at the same time. Or you can ungroup together. You can do all the channels if you want. Cross crossovers. Pretty much simple here. This is our mid-range speakers in the system, Butterworth, Linkwitz, Riley. We have all that available. We have slopes. Right now, this particular channel is a bandpass crossover. If you want to make it nothing more than, say, a high pass, you come down here to the low pass and you simply set flat. If you notice, this mutes out, which means now this is only passing signal above 80 hertz. Same thing, if you want nothing but a low pass, you go in like that, and that's what you get. So in this case, we're going to put it back to bandpass since we're on an active system. Also down here, there's been questions in regards to this panel here. It says low input right now. This is a meter input system. What this is these are color-coded indicator lights that if you put full range pink noise into your source unit and you follow the color indicators of those lights, they will change colors. And it'll let you know the indicator here on the top or the text box in that top bar will tell you if you have good signal or low signal. The reason why we did this is a lot of people were not really driving the input signal correctly or setting their input gains correctly, and they would max out the gains on the amplifiers, and then they would call us saying they have system tests. These meters here are a good indication of how to actually do it, but most importantly, the other important one is over here on the right-hand side. These meters over here. These meters here will go up in signal and down in signal if you have signal passing through them. But at the same time, these colors down here and how the colors of the bars here are affected, you can come into options. Oops, let me drag this over here. And you can actually change where you want the colors to indicate. Red does not mean bad. Red just happens to be what the level 4 number is. If it goes beyond the top of the meter, then yes, you're probably clipping it. You'll also see clipping indicators down here on the bottom. You can change the opacity of the labels over on the meters as well. If you have a slower computer, you can also change the update speed of which these actually respond. So if you have a fast computer, use a high update speed. If you have an older, slower computer, use a slower update speed. Couple of the cool things that we are looking that we're actually adding in this more coming up date is if you've ever used REW, for the guys that like to use REW to do a somewhat of a system tune, we are going to be bringing REW compatibility into the Pro-Series DSP. Basically, what this allows you to do is use REW to create create your adjustment curve based upon the recommendations for REW, and you can load that REW file into the system. Give you just a little idea. You can come in here, you can open up the REW response, your target curve, or your REW EQ curve, load it in here, and this will actually make all those adjustments in the EQ for you. Is it going to be as accurate as doing it yourself? The answer is no, but a lot of guys love using REW for some of the higher advanced phase and acoustical response corrections, which this is good for. That's another course at another time, but we will be bringing out the REW compatibility here shortly. Connection, as you see, Wi-Fi configuration. We're also working on getting the Bluetooth adapter out too, so that way you guys can plug the high-res Bluetooth directly into any of the Pro-Series DSPs. Come down here on the next tab is mixer. Now this is your standard mixer, and there's been some confusion. Some people don't understand it. But basically, if you remember right, when you reprogrammed, the names, this is how you typically have things here. So this is your input signal, inputs 1 through 8, and this here is your output signal. So in this case, we have a bunch of cheater buttons down here on the bottom. Three-way sum. You can click it. It gives you a general concept for some systems on how to route. But the way this works is if you have input coming in right here on input 1 on the left-hand side, and I'm hoping it's showing my cursor, and you come over here to where the first box with 0.00 is and go up to output 1, that is the path that signal is taking. So input 1, which is my left channel input from my source, is being transmitted to output 1, output 3, output 5, 6, and 7. And then my right signal is being sent to output 2, output 4, output 6, and output 8. Now, you're probably asking, why aren't these names changed right here? If you remember, if you open up the mixer assistant, this mixer that we're looking at right now is this one. So these names across the top are actually right here, not over here. Hopefully that makes sense to everybody on that one. But just remember, you can assign any variation of inputs to any variation of outputs. If you're doing mono, you do left and right like we did here. And this actually allows you to route the signal in what you need, depending on how many channels you have coming into the system. If you're using Maestro, you will not have access to this panel here. You can come into the panel, but none of these adjustments here are selectable because Maestro configures it specifically for the vehicle that you are doing the application in and gets you routed correctly. And then, of course, your input sensitivity over here, you can adjust everything from 0.5 to 32 volts. These two are the most common ones, depending on what source you're running. Yes, if you put it at a lower voltage and you're running a higher level voltage input, it will give you more volume. This is not a volume control, it's a sensitivity input. If you do go from, say, if you have an 8-volt source unit and change it to 2 volts, you do risk getting background noise. But then, of course, the question that we ask is, how do you set gains? Well, once again, in conjunction with the indicator lights on the bottom, we are also going to be bringing out a gain wizard. And the gain wizard is a great little tool here where you put paint noise in the front, you select the channels that you either do or don't want to have it adjust, and you click run, and this automated tool will actually adjust all the gains in the system for you. No more guessing, and it will optimize them based upon the signal that you have coming available from the source itself. So that is another update that we have coming. And then if you are doing an integration DSP and you do not have an option like the Maestro module or something like that, over here on the integration DSP tab, you have the options for input equalization to do correction with, as well as delay and phase. And then most importantly, for the tuning process, we talked about muting the speakers. We have all of these down here across the bottom. That is your muting. Now, this here is a global mute where it says mute all on the left-hand side. If you mute that, it doesn't matter what preset you are on, it's going to mute all the channels. But if you click on check all, it's only going to mute these individual ones here, which is only going to mute the active preset that you are on. And if you're running more than one processor, something that's also unique to us is you can run more than one processor on a system, where you can actually come in here, go to the product selection. If you have 2 processors and 2 USBs plugged in, you come in, you name the processor. You know, I only have one hooked up right now, but we'll just say it's Fred's desk processor. And now if I had more than one processor hooked up, every time I come in, it renames it. It's limited in numbers. But if I had, say, desk processor 1, desk processor 2, do these 8 channels, I simply come down, select from the drop-down menu, it'll populate however many processors I have hooked up to it. And I can tune everything through one piece of software, doing ultimately an 8-channel, 16-channel, even 24-channel system. So lots of really cool toys in here. The processing and setup for the way the software was configured in this was really designed to be something that puts the power of tuning back into the hands of the tuner. We're taking out the engineering aspect of this, as far as we don't want the engineers to actually define you know, how a system should sound. And that's one issue you have with auto-tune DSPs. The reference curve they're going after is defined by one person's opinion, not the person who has to listen to it. If you follow these processes and steps that we've given you, you'll learn how the process happens. And with practice, you'll become proficient. But most importantly, you're going to make yourself knowledgeable with the software, and you can make it very quick and very easy to use. Let's see here. Julian, can you use a passive sub or your passive USB hub with 2 processors, or do they need to go direct to the laptop? To be honest with you, that is going to depend on the hub. We have had some people who did, you know, they had 4 USB ports hooked up 4 processors, not a problem. We've had one person who did 1 USB connection back to the hub and bought a very crappy hub. And I think he went through 7 or 8 different hubs before he found one that would work, because not all hubs are built different. And the thing to remember is when it comes to USB, every connector in a USB signal degrades the signal. And if you check with USB, they actually only guarantee communications up to things 6 feet. So if you are going to use a long USB cable like the ones we sell, the USB micro or the USB 20 AB for the PS8, that's why we sell it in one long cable, because some people like to run the cables and they'll put like a panel mount connector up at the front of their car, so it looks cool and they don't have a cable laying someplace. The problem is depending on the quality of that connector and the quality of the cable, it can render some unwanted issues, and can give you some results that you may not like. So what we're doing is we're actually just making sure that we give everybody the option to do the single cables. If you do a hub, spend some money on a good one, but we can't guarantee the hubs are physically going to work correctly.